Hey guys, we're gonna go over the Unit 4 review, okay? So it says represent each series using sigma notation, okay? So sigma is just this, Greek letter epsilon, and we just say n equals 1, okay? And then we need to say, okay, how many terms are there total? 1, 2, 3, 4, 5, 6, 7, 8. Now, there's not a dot, 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 so that means this stops at 8, okay? And then the next thing you need to do is put in the explicit formula. But right now you might be saying, I don't know the explicit formula. So let's go back and look at our series. 5, 9, 13, 17, 21, 25, 29, 33. How does it look like I'm going from term to term? That's right, I'm adding 4 each time. So I can say that D is equal to 4. Okay? So then what I can do is I can just simply say A sub n is equal to the first term, which is 5, plus the common difference, which is 4, times n minus 1. Okay? And now, you multiply the 4n, so that gives you 5 plus 4n minus 4. And the last step is just to put like terms together, so 5 and negative 4 make 1, so you get 4n plus 1. And that's your explicit formula, so right in here you just write 4n plus 1. And that's it. That's all I need to do for problem 1. Alright? We had 8 terms total, so we wrote from n equals 1 to 8, and then this is our explicit formula. So this just means if we ask this question to you, it just means find the sum for the first 8 terms of 4n plus 1. Alright? Let's try doing problem number 2 now. 3, 6, 12, 24, 48, and 96. How does it look like I'm going up each time? That's right, I'm multiplying by 2, so this is geometric. So r equals 2. Okay? So we know we're going to need the explicit formula, so it's just going to be a sub n is equal to the first term, 3, times 2 raised to the n minus 1. Alright? That is our geometric explicit formula. So we write the sum of, we say n equals 1, then it says dot, 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 so we write our infinity symbol, okay, because that just means it keeps going on forever, and it doesn't give us a total number of terms, and then we just plug in our explicit formula. 2 raised to the n minus 1. And bam, that's all she wrote. Alright, number 3, it just says 1 half plus 1 half plus 1 half dot dot dot. So that just means we're going from n equals 1 to infinity of 1 half. Because we're just trying to repeat 1 half over and over and over and over and over again. And that's all we need for problem 3. Okay, problem 4, represent each sequence using a recursive formula. Okay. Recursive formula is just a sub n plus 1 is equal to a sub n. Now, if it's geometric, we need to say times whatever r is. So you need to figure out what r is. If it's arithmetic, we say plus d, but you need to know what d is. So let's go back to our sequence. 3, 8, 13, 18, 23, 28. How am I getting from each term to each term? That's right, I'm adding 5. So I just say plus 5. Alright, let's go to number 5. Same idea. A sub n plus 1 is equal to a sub n, and then I just need to figure out if it's geometric or if it's arithmetic, and then I just need to say either times r or plus d. So 3, 3 halves, 3 fourths, 3 eighths, 3 sixteenths. What does it look like I'm changing by? Well, let's just say mental math is not your game. And so you're like, I don't know, Miss Dillon, I got no clue. Okay, no sweat. Grab a calculator. Type in your second term, divide it by your first term. Okay, so that would be, if this is geometric, then the r would be 0.5. So let's check the third term divided by the second term. And if we get 0.5 again, then we can say it's geometric. Okay, divided by 3 halves. And we get 0.5, so it is geometric. So r is equal to 0.5. So in this case, I just need to say times 0.5, or times 1 half, whichever you feel like writing. And that's all we need for those two problems. Alright, let's go on to problem 6. Problem 6 says evaluate the sum of 4 raised to the k minus 1 from terms 1 to 7. Alright, so this is a geometric situation because I have a variable minus 1, so I know it's geometric. Okay. And then I should remember that the geometric finite sum is S sub n is equal to the first term. Okay, so we need the first term. So let's plug in a 1 here. So we plug in a 1 for k, so we get 1 minus 1, which is 0. So 4 raised to the 0, what is anything raised to the 0 power? 1. So we have 4 raised to the 0, so that's just 1. So our first term is 1 times 1 minus r, which is 4, because r is the number raised to the variable minus 1, raised to n, 7, divided by, that's a divide by, I did that really poorly here, let me back that up, divided by 1 minus r, 1 minus 4. Okay, so now we're going to let the calculator do the rest of the thinking for me. So I'm going to say 1 times 1 minus 4 raised to the 7th, okay, divided by 1 minus 4. Press enter, and we get 5461. Alright, so the sum of the first 7 terms is just 5461. Awesome job. Okay, let's go to the next problem. Alright, the next problem says sum up the terms 1 to 7, okay, with this explicit formula. Now, hopefully you realize, oh, that's an arithmetic explicit formula. Okay, so then the arithmetic formula is s sub 7, because that's how many terms I have, 7, is equal to n divided by 2, so 7 divided by 2, times the first term plus the last term. Now, when you look at here, you're probably going, I don't know what the first term is. Okay, well, that's not hard to find, right? Just plug in a 1. Okay, so we get 7 minus 3. I don't know why I put 3/4 in the parentheses. 3/4 times 1. Okay, well, 3/4 times 1 is just 3/4. 7 minus 3/4 is just 6.25. So our first term is just 6.25. Now we need to know our last term. Okay, so instead of plugging in a 7, I'm just simply going to plug in a, I said that wrong. Instead of plugging in a 1, I'm just simply going to plug in a 7. So I'm going to let the calculator do the thinking for me on this one. But to get the 7th term, I would just say 7 minus 3/4 times 7, because I plugged in a 7 for n, and I get 1.75. So 1.75. Okay. And now I'm just going to let the calculator do the thinking for me here too. So let's see. Oh, before I plug in the calculator, I made a small error. That should be a plus sign. My apologies for putting it differently. Okay. So 7 divided by 2 times 6.25 plus 1.75. Press enter, and I get 28. So the sum of the first 7 terms would just be 28. Bam, there's my answer. Oh, I don't know. I am not on the right word document anymore, am I? I paused the video to check something, and that's not the right Word document either. There we go. Now we're on the right Word document. Sorry about that. All right. So, yeah, that's all you have to do for problem 7. All right, let's try problem 8. Find the sum of 1 to 8 of a sub n with the general term a sub n is equal to negative 3 times 1/2 raised to n minus 1. Okay, so this is just the explicit formula. That would just go right there, okay? It's the same type of problem as this one, okay? Because this is geometric, all right? So this is a finite geometric. So once again, I'm going to say the sum of the first 8 terms, so s sub 8, is equal to the first term. So I'm going to go plug in a 1 for n right here, and that's just going to give me negative 3, because 1/2 raised to the 1 minus 1. 1 minus 1 is 0. So 1/2 raised to 0 is just 1. Negative 3 times 1 is just negative 3. So negative 3 times 1 minus r, which is 1/2, raised to the 8th power, all divided by 1 minus r, which is 1/2. Okay, so now I'm going to go let the calculator do all the heavy lifting for me. So I'm just going to say negative 3 times 1 minus 1/2 raised to the 8th power divided by 1 minus 1/2. Press enter, and I get negative, I'm just make sure I typed in everything right, but I get negative 5.976, which I'm just going to round it to negative 5.98. Alright, just double checking that I typed it all. Yeah, typed it all in just fine. Alright, so I'm going, okay, negative 5.98. Looks good. So the sum of the first 8 terms is just negative 5.98. Awesome. Alright, let's move on to problem number 9. Alright, problem number 9, I'm not actually going to write anything down because this can all be done simply. Ooh, I went too far. This can all be done simply through the use of a calculator. Okay? So problem number 9 says, calculate the 8th term, a sub 8, okay, for each one of these. So really, guys, all you're going to do on every one of these is just plug in an 8 for n, or whatever the variable is, which I think is n for most of these. So 450 times 1 divided by 4 raised to the 8 minus 1, which is just 7 if you want to plug that in. And I get negative 0.99. So right here, all you do is type in negative 0.99. Okay. Wait. Let me double check something real fast. Let me put this in parentheses and see if that changes the game at all. Yes, okay, so let me tell you why this answer didn't stick right with me for a second. I looked up here, and I said, I'm doing 450 times 1/4. At no point in time will I ever be multiplying a negative anywhere in there. No matter how small I make 1/4, no matter how many times I raise it to any exponent, at no point in time should it become negative. So that's why this answer didn't stick right with me, and I realized that this calculator is doing all this part and then minusing that number by 1. I don't want it to. I want it to raise it to the 7th power, so I just had to retype it in. So it's just 0.027. So that's the 8th term, 0.027. All right, let's do problem number 10. Negative 22 plus 8 minus 1 times 4. And we get 6. Easy. And then on problem number 11, it says a sub n is equal to 75, so the 8th term is going to be 75. All right? Number 12. Calculate the infinite sum if possible. Remember, you can only calculate infinite sums on geometric situations where r is between negative 1 and positive 1. So we look here, we go 1/2, 1, 3/2, 2, 5/2, 6. Okay? So the question becomes like, how am I going from each term? Okay? How am I making this magic happen? Well, hopefully you quickly realize that this is not geometric at all. Alright, so we can check that by saying 1 divided by 1/2. So second term divided by first term. And then we could check that same idea by doing third term divided by second term. And I get 1.5. And so you notice that it's not the same. Okay? So therefore, number 12, you can't do it. It's not possible. Alright? Number 13, 64, 16, 4, 1, 1/4, 1/16. Alright? In this case, you're multiplying by the number 1/4 each time. Okay? So therefore, that is geometric. That r is between negative 1 and 1. So it is totally possible to solve this problem. Okay? And we just use the infinite sum formula, which is s is equal to the first term, so 64, over 1 minus r. So 1 minus 1/4. Okay? So we just grab our handy dandy calculator and let it do all the heavy lifting for us. So we're just going to get 64 divided by 0.75, because that's what 1 minus 1/4 is, and we get 85.3. So the sum of this infinite geometric series, with r being between negative 1 and 1, specifically r was 1/4, the sum is 85.333, repeating. 0.3 repeating. Alright? Okay, let's move on to number 14. Alright, it says, write the binomial expression. I'm going to need a little bit more space for this, so 3x minus 2 raised to the 4th. Okay. You guys should be able to squeeze it in there. It's just hard for me to write small using this. So it is 3x minus 2. Alright, so this is what I would do. I would go look at your Pascal Triangle. I would go down to the 4th row. You're going to write out the 4th row's coefficients, okay? Which is 1 plus, I'm trying to see if I don't have that memorized, so let's do Pascal Triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. All right, there we go. That's our fourth row. All right, so my coefficients are just 1, 4, 6, 4. Oh, I forgot a plus sign. I'll just put it right there. 4, 1. All right, and we take our first term and we raise it to all the power, so it's 3x to the fourth. 3x to the fourth. And now our first term will go down in power as our second term goes up in power. So now we have 3x to the third and negative 2 to the first. Then we repeat that. Our first term loses a power, so 3x squared negative 2 squared. Our first term loses a power and our second term gains a power. 3x to the first, negative 2 to the first, to the third. And then our second term has all the power now. Okay, so now we just need to go through and simplify. 1 times 3x to the fourth. Well, 3 to the fourth is, I'm not honestly sure what 3 to the fourth is off the top of my head. I think it's like 64 or something. But I really could be wrong. 81. It's 81. I don't know where I got 64. 64 is not even divisible by 3. All right. 81 times 1 is just 81. So you get 81x to the fourth. Okay. Next problem. 4 times 3 cubed times negative 2 to the first. All right. So 4 times 3 cubed times negative 2. I get negative 216. So minus 216. And then we're still going to have x being raised to the third power as well. So x to the third plus 6 times 3 squared times negative 2 cubed. Times negative 2 squared. Okay. So 6 times 3 raised to the second times negative 2 raised to the second. It's always good to put powers outside the parentheses. I know I didn't do it here because this 3 is positive, so it wouldn't make a difference. But here where it's negative 2, it will make a difference. So it's just always good to put powers outside parentheses. So press enter, and we get a positive 216. And then don't forget your variable. You still have an x squared happening. All right. Then we have 4 times 3 times negative 2 cubed. All right. Well, 4 times 3 is just 12. So you're going to get 12 times negative 2 raised to the third power. We get minus 96, and then there's just x to the first power, so just x. Last but not least is 1 times negative 2 to the fourth. All right, well, negative 2 to the fourth is just 16, so we're going to get plus 16. We are done with that problem. Well done, well done. Okay. All right, our next problem is expand x squared plus 4 to the third power. Okay, so x squared plus 4 being raised to the third power. All right, so go back to Pascal's triangle. Look at row 3, 1, 3, 3, 1. So we get 1 plus 3 plus 3 plus 1. All right. So take your first term, raise it to all the power. So we're going to get x squared raised to the third power. So x squared being raised to the third. Then we drop our first term of power. So now we get x squared being squared. And then that's going to be 4 to the first. Then it's going to be x squared being raised to the first. 4 to the second. Alright. Then last but not least, x squared will be completely gone. And it's going to be 4 to the third. Alright. So 1 times x squared to the third. Power raised to power. The powers multiply. 1 won't change anything, so we're just going to get x to the sixth. Plus, let's see, 3 times 4 to the first. 4 to the first is just 4. 3 times 4 is 12. X squared squared. Power raised to power. They multiply, so it's x to the fourth. Alright. Plus, 4 squared is 16. 16 times 3 is something. It's early, so I don't have this memorized. 48, so plus 48. X squared to the first is just x squared. And then plus 1 times 4 cubed. 4 cubed is 64. That's why I thought 64 earlier. Alright. 64. And then times the 1 didn't change it. We are done. There's nothing left to put together. These are all different terms, so I can't simplify any further than that. Alright, next problem. Problem 16. A hardware store makes a profit of $30,000 during its first year. The store owner sets a goal of increasing profits by $5,000 each year for 7 years. Okay, so one, you should already realize, oh, that's going to be arithmetic, with D being equal to 5,000. Alright. Assuming that this goal is met, find the total profit. That means find the sum. S-U-M. Find the sum, okay? This is arithmetic sum. So I need to know the first term, and you could say I need to know the last term, but I don't really feel like writing an explicit formula. So instead I'm going to use this altered version of the sum formula, where it's A sub n is equal to n divided by 2 times 2 times the first term plus D times the plus the common difference times n minus 1. Alright, so I'm just going to plug into my calculator. Alright, I'm not even going to write it all out. I'm just going to plug in my calculator. Alright, how many years am I looking at? 8. So I'm going to get 8 divided by 2, which is just 4. If you just wanted to put 4, that would have been okay. Times 2 times the first term. How much money did he make during the first term? $30,000. That's exactly how much profit he made. Plus, the common difference is 5,000. Times, how many years am I looking at? 8 minus 1. So during his first 8 years of business, he made $380,000. He made a profit of $380,000. Easy breezy. Alright, let's look at the next problem. Problem 17. An object with negligible air resistance, do not count any air resistance, is dropped from a plane. During the first second of the fall, the object falls 16 feet. During the second second of the fall, it falls 48. Third second falls 80. During the fourth second, it falls 112. Assuming this pattern continues, how many feet will the object fall in 8 seconds? Guys, that means total in all 8 seconds. Not just during the 8th second, but during all 8 seconds. Alright, so that means I need to find a sum. And 16 to 48, 48 to 80, that's 32. So I'm falling 32 feet. Alright, but we're not going to make it negative because you'll notice it doesn't say negative 16. It just says 16. So D is going to equal 32. Alright, so once again, I want to find the sum, so I'm going to use the same formula right here, the same one I just used. I'm going to let the calculator do all the heavy lifting for me. Alright, so we're just going to say n divided by 2, so how many seconds total? 8. So 8 divided by 2 times 2 times the first term, so how many seconds did it fall? I mean, how many feet did it fall during the first second? 16, okay, plus the common difference, 32, times n minus 1. So 8 minus 1, which should just be 7. Oh, I put 11 there on accident. Press enter, and we get 1,024. So during all 8 seconds summed together, it fell 1,024 feet. Alright, I know I rushed through part of this, guys. I hope it was helpful. Please let me know if something didn't make sense or I made an error or you just have a question, alright? You can either shoot me an email or you can hit me up on Remind, okay? Or just ask me during class if you're watching during class, alright? Thanks.